It's the SDG Podcast. Before we get started, you can check us out on the web at solutiondesign.com/podcast or find us on all the social medias, LinkedIn, Twitter, Facebook, and Instagram at Solution Design Group.
Welcome, folks, to the SDG Podcast. It's a little weird. Kyle usually does our intros. Kyle's not here today. It is me, Chad Jettner, and some friends. We're going to talk about LP programming, linear programming, what that means, what our experience is with it, and what pain points we've had, other stuff like that. I'll introduce my friends one at a time. Cam?
Hi.
Yeah.
I am Cam. I'm a consultant at SDG, like everybody on this call. I'm currently working on a linear programming project in the advertising space. So that's an optimization for I have money to spend on ads. What's the best way to spend it?
Perfect. Ben?
Hi, everyone. I'm Ben. Also, consultant. And I just wrapped up a project related to sort of warehouse management and combining ingredients into a product subject to constraints. You only have so much inventory. How do you put it together to produce the product to order?
All right. This is going to sound weird because me, Brian, and Greg, who we're going to meet next, are all solving kind of a similar issue, kind of. So go ahead, Greg.
Yeah, I'm Greg, same consultant. I'm actually working on not the same project, Ben, but the exact same problem. So we're essentially creating recipes based on inventory we have to fill orders.
And finally, my friend Brian Cofield, also known as Sweet Sweet Baby J.
Howdy. I'm a Java developer by trade, but we've been working on this, I guess it's supply chain management, linear optimization, matching supply and orders.
Perfect. And I'm Chad Jettner, consultant. We're all at STG. We all have had exposure to linear programming. That's been our life. That's been my life for the last 5.5 years, and as long, if not longer, for everybody else on the call. Can we maybe just start off? I know, Cam, you gave a whole presentation last year at our OSN conference around linear programming. Do you want to just outline like what it is, what it isn't, maybe more specifically, and how it came about?
Yeah. So linear programming, very briefly, what it is it's you have some problem and you want to find the best way to solve it. So it's an optimization thing. So for example, in the advertising space, I might want to find the best way to spend my money, where best might mean getting the most eyeballs to see my ad. And you would have some constraints on that, like the amount of money I'm willing to spend on ads is a finite resource. So it's those, find the best way to do something subject to a set of constraints. Historically, it was developed, it came out of World War II. I believe it was invented by some Soviet dude working at a plywood factory. And then simultaneously in the US by George Danzig working for the US Air Force. And they were solving problems with like supply chain stuff or best allocation of resources, and then also like the offensive version of those problems, where if you want to mess up your enemy's supply chain with the like minimal amount of bridges, for example, you'd have to blow up to mess up your enemy's supply chain.
Is that true? Is that true? So like, it really became like an offensive weapon against the other side to say, here's the fewest amount of bridges we need to blow up in order to.
Yeah, they've used it those ways. If you've heard, there's sometimes in like discrete algorithms courses, like max flow, min cut problems. Those are actually LP things, and the min cut is the minimum number of bridges to blow up, and the maximum flow is the maximum amount of resources you can send across those bridges.
That was kind of so we're not solving that problem. I kind of wish we were though. That sounds like a lot of fun. Also, we
Our
should say,
clients are not on the offense.
yeah, we're more capitalist than anyway. And we should say really quick. Now, Cam and Ben, you guys both have PhDs in some mathematics field, right? Is that accurate?
Yeah, my PhD, it was from a department. It was actually called Combinatorics and Optimization department. So there was a lot of this linear programming in it. It was halfway between the math and computer science department at the school Waterloo in Canada. And it's this sort of weird department. The university was founded after World War II, and they tried to establish a good department by recruiting all of these old World War II guys doing things like blowing up bridges. They gave them their own department.
Yeah, I have my
Alright,
PhD in particle physics. I didn't work on linear programming directly, but a lot of the math I did was so closely related that when I saw it for the first time, it wasn't scary.
Okay. All right. And Baby J, you don't have a PhD, but you do have your major was you have a math major, right?
Not even close. Yeah, not a doctor. But I do have undergrad in math and computer science.
Perfect. And I'm just a dumbass. I'm on the project, and I think it's so we should talk about like from a develop. So me, Baby J, and Greg, we're all like Java guys. Like historically, we've built, Java, Spring Boot applications, relatively established patterns, right, Greg? Like nothing insane until we get to these problems, which are, I think, I mean, from my experience level, the problem we're solving right now is very, very different than anything I've solved in the past as a developer, right?
Yeah, for sure.
Yeah.
I'm actually really curious how y'all are doing it. Like, what's the technology over there you're using? What are you coding this up in?
With Java. So Gurobi, can we say Gurobi? Gurobi's the vendor we're using. They have
I
they have
see.
lots of different APIs. I mean, their APIs in a lot of different languages. It all boils down to their C implementation, but so the
Yeah.
API isn't necessarily
Yeah, I think
that.
Gurobi answers my question. They're the one with like the optimization algorithms under the hood, right?
Yeah. Yep.
But even I'd guess that like Grub is not a magic wand. You would have to be pretty smart about how you use it.
Yeah.
I would
So
think. Can
like,
you either like make stuff way better or way worse depending on your setup?
yeah. So I've worked on two projects here involving LP, and both of them have had, we have a data scientist, somebody with a doctorate in basically mathematics of some sort that kind of builds the model for us, right? And so, he's the one that ensures that we're, I guess, feeding the input correctly, and building up the constraints and the variables and the whatnot correctly, right? And so mostly my job has been to kind of just integrate with that model, right? So I work mostly on the app side where we, take our data and we kind of turn it into this, what we call an LP format, right? Basically put it into a format that model understands. And then on the flip side, once that solve is done, we take that data and we turn it back into something that the application understands that output, right? Because the two things don't speak necessarily the same language. They're because I mean you have to define your problem as a mathematical problem, right? And it's
Greg, who's your user? Like, what's the profile of your user? Are they like also pretty deep into the data, or is it someone higher level?
no, they're not. I mean, they get deep into the data only because they have to with these solves because they're so data dependent and everything is so tied together. But the user is, I'm at a client that produces food for people, and that those products can be made up of several different ingredients, right? Sometimes 40 or 50 different ingredients and different combinations to make them up, right? Depending on the constraints. And so the users are actually called formulators. They're the people that are responsible for coming up with the formula or the recipe to be used for the day that then gets sent to the plant and tells the plant how to actually mix all of this stuff, right?
That's basically exactly what I did with my client too. There, we actually had a formulate button
Yeah.
that under the hood did all the calculation,
Yep. Same.
and the user, basically, yeah, was a formulator. Got it.
Yeah. Yep. The user's job is really to mostly
They've got an
kind of
order sheet, right? Like
yeah,
they
we have all that automated. We pull in all of the orders, we pull in all of the supply that we have, future supply, but it's not 100% accurate. So the user's biggest job is to make sure that all of that is in line before they formulate, right? To make sure that what they think is coming inbound is actually in the app correctly, so that our solve understands what's coming in, what the supply is, right?
Yeah, to compare, what you've got with ours is, it's basically like the UI is a warehouse inventory, and then the user just sort of plugs in the product properties that they want. So, okay, like just for example, the output color should be this, and the output, sugar content should be that,
Yeah.
and so on. And uh, locations of origin for each individual products need to be 50% Midwest or something like that. And then you hit the go button and it tells you which items in inventory should be used.
Yeah.
Yeah,
That's exactly what ours does. Yep.
pretty much the same problem, right? Like, Brian, I think I'm not speaking out of school here. Like on my side, so like we've divvied up our project. So me, Brian, and Greg, we've all been on our same project for a degree of time, and we divvy it up between like there's Java resources assigned to helping the data scientist, the LP team, and then there's the guy on the other side, which is me in this case, building up just the infrastructure and everything around that to support feeding data into the LP model. At least that's how it started, right?
Yeah.
And so a lot of my day-to-day is still just like supporting the infrastructure around the mathematical model. Brian these days, it used to be Greg, now it's Brian, is way more deep into like the actual care and feeding of the model that we built up, right, Brian? So like the mechanics of getting the constraints into the model, like the REST endpoints and the Java infrastructure and the enterprise infrastructure around that, I handle. And then you take care of like actually tweaking all of the constraints and all of the outputs of the model. Am I oversimplifying, or is that pretty good?
It's a really awesome dance, like between different disciplines and specialties. So like it's kind of a marriage of traditional like LP model stuff, and then like applied sciences, which is like how do you make computer systems operate at scale with thousands of requests per second? And then both of these need to work together because the model can't be too big, and it has to be relatively quick, and then handle threading and all of those concerns. I guess it takes either a really smart person or a bunch of really smart people to kind of pull it off. It's kind of impressive to see.
And I think you're kind of getting at a big difference between, it sounds like, Chad, Greg, and Brian, that your problem's very similar to Ben's, and it is, but yours is probably one of the biggest linear programming systems in the world, I would guess. The problem you're working on, and Ben's, I would guess, is one of the smallest, where I'd bet most people would need to get budget approved for whatever VM you have yours running in, and Ben can run his serverless.
Well, I don't know that we want to measure LPs right now here, Cam.
I do.
No, I'm just actually, like, they sound similar, but like they are very different in sizes.
No,
like,
no. I want to talk about scope here because scope, size, speed, and so on. I was really blown away to hear how important sort of speed and what you're sort of how many problems you're solving per, whatever, and it's happening automatically. This is not how it works for me. This is very with my problem, like the user sort of sets up their constraint, hits a go button about 50 times a week to fill their orders and is done.
Yeah, so ours is a little different. Like the amount, I think it's based on the amount of constraints that feed into our problem. Like we can kind of dynamically recommit product and raw material to solutions, but
Yeah.
it our big overnight solve, right? Like this is a big event. Like it's not a thing that can happen at a click of a button for the entire enterprise. It's a thing that happens. It's not a sub-second request. It's I don't know, what is it, like half hour, 45 minutes to an hour.
Depending on the
And is
Depending
it nightly or is it weekly
Well,
or something like that?
I mean, Brian, you can talk about it a little bit. Like there is the nightly thing. There's also like,
Gosh, I could eat up this whole hour talking about this fun stuff, but the overnight, yeah, that's the big one. That's like the normal one. Like from what I hear of other LP projects, like it's relatively normal to do these larger plan things. Then we have this medium plan that's much shorter than that, but it kind of has to stitch in and live within the larger plan and not modify the larger plan too much based on temporal, like date ranges, stitches those together. And then there's the little tiny plans that come in all throughout the day that also stitch in to the larger plan. And they all kind of have to live together. And we have to make sure that at the boundaries, when we're stitching them together, that nothing becomes infeasible.
So you can do
Which
like
is a
fast partial solves or something, and then
yeah,
your big
it's kind of
overnight job fixes it.
that's exactly right. Yeah.
Is the Garobi side of things super stable for y'all? And it's like all the work is stuff that you're doing? Or is like you mentioned there's a data scientist. I assume they're internal at the client.
Yeah. So mine, we're actually still in development. So like the model is not necessarily 100% defined, right? So we're rolling this out to different departments at the company, right? And so we're doing it in waves. And so and every department, they all supposed to kind of work the same, but in reality, they all have their own little quirks and different nuances. And so we find new things, mostly new constraints that we need to add to our model.
Mm-hmm.
Right? Something that this department does that the other one doesn't, that we just weren't aware of when we built the initial one. But
Mm-hmm.
I would say that
yeah,
too. It's not on the Garobi side. We've had like calls with them to try to figure out whether they need to do something for us. It's always, I mean, they haven't had to change anything. I guess. Is what
Yeah.
I'm saying.
Yeah.
it always seems to be like, we work with multiple plants and multiple suppliers and everything else. The tweaks to the model are always business process tweaks, right? Like, oh, these guys do this thing this way,
Yeah.
or like this customer wants it this way, so we have to tweak the model to produce, desired outcomes, right? Which means, yeah, it's never like. I very much appreciate Garobi for what it is. The implementation issues that we've had with Garobi have not been around the math or anything else. Like it solves what it solves efficiently, and you get out of it exactly what you put into it. It's always the stuff we're putting into it that changes, right?
Yeah.
And then,
Yep. I understand.
yeah.
Yeah, that's been my experience too, that the hard part isn't coding up constraints. The hard part is talking to all of the business people that have been doing this manually and figuring out what all the constraints that need to be coded are.
Right. Because most of them are second nature, so they don't know until the model doesn't do what they want. And they're like, well, do you have this constraint in there? You're like, well, no. Did you tell me about it? Well, that's the way we always do it. It's like, well, that's
So can we talk? So Cam's doing a similar thing, but on like a different axis. Can you compare, Cam, like before we get too deep? I don't know. I don't know. Is that okay? Is that a good turn to take right now?
Yeah, so mine it's maybe kind of a medium scale between the two supply chain problems. So it's all running on open source stuff, not Gurobi, and there's a lot of forecasting involved. And I've mostly been the data scientist doing that forecasting as well, in addition to setting up the linear programming. So I've had like a lot of contact with the business teams being like, how would you forecast this? That doesn't make sense. You silly data scientist, go back and try it again. Like getting all of the constraints and getting them all coded into the system. Yeah, so
The forecasting
it's
forecasting is a separate problem from the linear programming.
yeah, the forecasting's a separate problem, and then we use the forecasted values in the linear program.
Okay. So I have an issue, not an issue, but my client, and it's the same with the project that I worked on, Chad and Brian with, was they're using the LP as an optimizer, right? So like in the case of the project I'm currently on is to just optimize the formulations, right? Recipes. And our objective is cost, right? That's minimize the cost is one of the big objective functions. But they have this perception of it, and I think it's because of the project that we were on, Chad, Brian, that it is a forecasting tool by itself, right? And they were very surprised to learn, like, hey, this is not a forecasting tool. This is an optimization tool. Yeah,
What do you mean?
they
How is
are.
it conceived of as a forecasting tool?
So, try to figure out how to word
I've
this
seen
without
that
saying too
too,
much.
where
But
because it has forecasted values going into it, it's
well,
like mine,
that's yes,
it's advertising one. So it's like telling you what decision you should make based on your guess about the future.
yes.
So if you're like guessing this many people will be watching the Super Bowl or something, and you're making a
Yeah.
decision based on that, your model
Well,
tells you the decision
yeah.
that you should make. But like if your information was perfect or within tolerances you built into it, but it's different than like just because the model's telling you to do that. Like it's only good if the forecast is true.
Yeah, if
And
A, then B, but if A is false, then
Right. It's garbage in, garbage out, right? And so that's where I'm at right now is we're kind of stuck trying to use this to forecast. So in terms of formulating food, they want to know which ingredients to order. And they want to know 6 to 9 months out. Like what should we be ordering for those raw materials, right? And I explained to them, and and when they brought me on for this, I explained to them, I'm like, well, an LP isn't going to tell you what to order. It's going to tell you the most optimal blend to make the product, but it's not going to tell you what you need to order unless you kind of give it a forecasted set of supply, right? Like, here's what you could possibly get, and given what you could possibly get, what formulation then would you use? What would be the most optimal one? And then based on what that is, then you could sort of say, well, this is what we should buy for supply, right? But it's kind of a chicken and the egg problem, right? You're using this optimizer, you're telling it, here's the supply you have to fill demand, and then see what it use, and then using those numbers to tell procurement what supply to buy, right? So
yeah. It seems like you need a feedback loop there where you do one, then you do the other, and then you go back and revisit.
yeah.
Is that
What I've been trying to do is I oversupply my model within reason, meaning I give it plenty of options just so I can see like what would be the optimal way to fill all of these orders that are on record. If supply wasn't necessarily an issue, if supply wasn't the bottleneck, right? If it was purely price, how would we go about doing it, right? And so, but because of that, my client thinks that it's a forecasting tool, but it's really not, right? It's the forecasting is actually all of the forecasting of what our supply and what the cost of that supply might be in the future. You know what I mean?
It sounds like a problem that a data scientist has to deal with on a regular basis. Do you consider yourself a data scientist, Greg?
I didn't. I do now.
I think you should. I think you should.
So here's one of the things I've learned with LP, which it was kind of surprising. And so one of the, I guess, the pros and the cons, like, doing what we do, we always say like computers always do exactly what you tell them, nothing more, nothing less. But I feel like when you come to an LP, it's even more so. Like there's no, because really it's just a math equation under the covers,
Yeah,
right?
like it's totally deterministic.
Yeah, but
It's just like big.
yeah, but like one of the things, when I first learned to like actually kind of build one myself with the model in, if we use our example, Ben, where we're formulating, just ingredients, right? And the client, their objective is to minimize costs, right? Like tell me what blend is the cheapest to use to make this product, right? And if you just went ahead and built a model naively with just that rule in there, that objective, what's really funny is the model comes back with nothing. It says don't blend anything because
That's the
Zero
cheapest.
pounds times whatever price is zero, and that is the lowest price that you can come up with, right?
Oh, really
Not-
quick. Can I just say, like, this is the Silicon Valley problem, right? Remember the scene from Silicon Valley where the one dude had AI help him eliminate bugs, right? And the best way to eliminate bugs was to eliminate all the software.
Just get rid of the code. Yeah,
Yes.
exactly.
The only way to win is not to play.
Yeah.
It's a Silicon
The only-
Valley war games.
The only reason I bring it up is because right from the get-go, we have this model, right? And the business has this one idea in mind that it minimizes cost. But in reality, the main objective functions in our model are cost is like, I think we have like 8 or 9 objective functions, and cost is one of the lowest priority ones, right? Because the first one is, hey, fill demand, right? Actually fill the orders. The other one is, make sure some of our ingredients don't expire, right? Age out, this sort of thing. But that immediately creates this, like, it doesn't work the way the business thinks it does in their mind. And so then we have a lot of tough discussions where they're like, well, I don't get it. Why did it not just use this ingredient here? That's the cheapest one. And it's like, well, because there's a lot of things going on under the covers, what you think is just minimizing cost, really you have to add 7 or 8 other objectives just to even get it to fill that order, right?
So this
That
is
is a good
interesting to me.
point.
Yeah, go ahead, Baby J.
Oh, it reminds me of kind of like interfacing with the business, and sometimes it's hard to explain why the model came up with the solution that it did. And in a lot of cases, you can explain it, but it's maybe not immediately intuitive to a business user why it's doing it.
Right. Yeah. Because
Yeah,
it's taken into
A lot of times,
consideration.
actually, I've had a lot of fun in QA. People will come to me and say, "Hey, how did this formulation doesn't make sense? Like, or we should have gotten a formulation, but it failed. And so I'm not understanding why I came up with this one or that one." And then I dig in, and the solver's right every time. It's never that there's a bug somewhere else. It's that nope, the solver just knew something that it's computers doing computer things and making very complicated optimizations in milliseconds.
Yeah.
But that's often how you end up learning about like business constraints that you weren't told about
For sure.
until like 45 minutes into that meeting where they're asking why it did the thing they thought is weird.
Yep.
Where it's like
Greg,
they're often right that it's not intended behavior, but from the computer's perspective, it's intended behavior. Just you need to add a line of code.
That's been the case on this project so much. And probably if I do another one of these, like the biggest takeaway is that like the business already knows what they want the output to kind of look like, right? And if we get all the constraints just perfect, then yes, it's going to look a little bit like that. They don't always love it when we come up with a different solution, and it might be, and I think we found this a few times on our projects, that our solved solution is a little bit better than what they're used to. But that's not what they built the business around. They built the business around like this old school process, and they just kind of want the solve to consistently. And I think consistency is the biggest, like the hardest thing to achieve in some of these, right? Because
Yeah.
Given the number of constraints, it's hard to achieve the same output every single time. We've gotten pretty good at it. We've gotten pretty okay at it, I think. But like we've been saying all along, like I think part of the problem with these isn't necessarily, I mean, it's hard. It's very, very hard building out these solves, building out the infrastructure around it. But the BDA ahead of these problems is almost as important, if not more important, than we are, right? Like gather all of the gathering requirements around these problems is so difficult.
Yeah.
And me and Greg and Brian, we're like 5 years into this, more than 5 years into this. We still find new stuff every day, you know?
Yeah, and the turnaround on these is slower than normal, just our day-to-day development stuff, because everything is so tied together, right? It's, you find a solution that doesn't maybe meet expectation, and that can be a 2-day turnaround just to figure out like, okay, was the solver right? And this is legit, but just maybe not expected, from you, because like you said, we have users that have been doing this for 2 decades, and so it's intuitive to them, like they just know this by the back of their hand, like it should be this formula, but that's the way we
Have you
always
had
do it.
to build any visibility tools, like
Oh
letting the
man,
business see why the solver's
I mean,
making decisions? Or
yeah, we've been trying to, but I mean it's difficult, right? It's because it's the question we get a lot is like, use why didn't it use this ingredient instead of this other, the one that it's using, right? And sometimes the answer is just like, well, I mean, they're basically the same, right? I mean, if they're kind of the same, if they have the same properties and the same price, then yeah, it's just kind of just pick one or the other. I mean, the reality, the other thing I think that the business doesn't really understand, that takes a while to get through to them, is like the solution we show is just one, right? There's actually many, many solutions that these LPs come up with. Um, and the one we present to them isn't necessarily the only one, right? And so like, yeah, the other solution could have just swapped those two ingredients and would have been fine, right?
So do you actually have degeneracy between solutions, or do you mean that like the solver finds lots of solutions around a lowest cost point, but the solver only shows you the lowest cost one?
So yeah, so I mean, in the end, we kind of have our MIP gap set at something like 3%, right? So it's we're not churning on it forever looking for the absolute minimum, because oftentimes, when you're
I
talking
see.
about the absolute minimum solution, and then the one that is maybe where the MIP gap is say 3%, the difference might only be a penny over a week or something. Do you know what I mean? So it's
Yeah.
technically cheaper, but
and
like, is it?
what's MIPGAP for the people who haven't heard that acronym?
Um, MIP gap is I don't know if it's a Groby thing for sure. I don't know if I think it's a LP model sort of general term, but it is a setting that basically tells your solver to say, hey, when you get within 3% of sort of the theoretical
Yeah,
most optimal solution, you can call it good and just return me that solution, right? At least that's my understanding of it.
yeah, that's mine too. I didn't
Okay.
remember what MIP stood for either.
I don't either, but I'm just regurgitating what our data scientist told me. So
Higher
But it's
higher
because of
value
those
means also more
min-max
quicker.
type problems where it's like the maximum amount of stuff you can send across the bridge is equal to the minimum amount of bridges you can blow up. So
Yeah.
once you get your
Yeah.
minimum within 3% of your maximum, you call it good.
I like that we brought this back to blowing up bridges.
Yeah, I was hoping we'd come back to that. Greg,
So-
can I ask? Sorry,
Oh,
go
go
ahead,
ahead.
Brian.
No, you
No,
go.
go ahead, Brian.
I was just gonna say, like, having only been on a large implementation of LP, I mean, we've done some small stuff too. That seems to go a lot quicker. For whatever reason, like the little models are just happily churning and they're not getting any bugs written against them. Like, I wonder if there's something to that. Like the added complexity makes a lot more headaches for business and developers.
I do think the complexity level of these is not linear, right? Like it is like
It's a hockey
meaning, yeah, you get to a certain point where you start adding more variables, more constraints, more whatever, and the complexity, if you add twice as many constraints, it's not twice as hard anymore. It's 4 times or it's five. It's, where it does reach a point where it's just like, man, is this even worth it? Because you spend all of your time basically trying to just verify that it in fact was the best solution. At least that's my experience, right? Because that's what I'm going through is they'll just say, well, why did it not use this ingredient? It's like, well, I don't know, it's the cheapest. But then they're like, well, prove it. I'm like, well, I just wrote a model that proves it. I don't know. Like, you know what I mean?
It's like linear programming systems. They
Yeah.
give a
So,
proof that their answer is optimal at
Yeah.
the end of it.
but when the problems are small, when it's something you have an app built around and you can click around and actually kind of in your head go through and look at like, okay, yeah, here's my supply. I see this is what I got, and here's what my order was, and here's the constraint, and you kind of just do it in your head. It's like, yeah, that makes sense. Right? Then you just move along a lot faster, and then people become comfortable with it, and then they stop, critiquing everything that comes out of it.
I think I'm
There's
spoiled
also-
with my relatively small problem. I've had, because we have like only 1,000 items in inventory at any time and, 50 constraints or something like that. And we're making one product at a time. And like making multiple products at a time is a feature that I sort of am still hoping to build someday for them. But, it's a much simpler situation. And actually, the priority is, okay, well, given the scope of this problem, I want to return an answer. So, I'll loosen the constraints a little bit if I have to, and in order to return an answer within 30 seconds and so on. And 99% of the time, the solver finds it within 5 seconds.
Okay.
Hey, can I ask?
Ben, didn't you have to, for a feature that I remember I heard that sounded fun, like you had to build a room for warehouse people to go rogue? Like if an ingredient sprung a leak or something, they'd be like, this one's going in the next batch no matter what. And your solver would have to work around their leaky product.
Yeah, I mean, I don't know about the leaky product color story didn't come up, but you are certainly able to inject one product. And there's lots of other fun things that we did. Like if you want to prioritize getting rid of older inventory first, that's in there. If you want to prioritize using inventory in one warehouse and not another warehouse, that's something that's in there.
Yeah.
Yeah, should we keep going? I bet we could check off all these
man,
buttons.
I mean, yeah, so far you're
So do you blend or you make multiple optimization? You do multiple products at once, I assume, right? That's the challenge, right?
Yeah.
Hundreds of products at once. Yeah.
Is
And
it hundreds? Is it hundreds or thousands or what?
I want to say hundreds. Maybe it's thousands. I don't know.
Yeah.
If we've reached thousands, have we?
This
I
is
think
where
it's-
the scope of the problem is no longer linear. Like I know because we're talking about matrices that will, is it not double in size, but
quadruple, right?
they'll get
Yeah.
they'll get bigger by a significant amount every time you want to add another product that you want to make.
I think it is orders of magnitude because I remember our first data scientist saying, I mean, this was back when the model was smaller, some billions of parameters.
Yeah.
By solve time, well, anyway, I don't know. You'd have to maybe Cam and I will go to a bar and work it out on a napkin or something.
Yeah. I'm inviting myself to that
Yeah.
conversation.
Well, the solve time isn't totally like
Yeah, that won't.
like the
that won't-
technology that you used, or even the one that I'm using for my open source software, would fail once it got to a problem their size. Probably is
Mhm.
like why Gurobi has a reputation for being one of the pricier softwares on the planet. Is sometimes you really need it.
But also, like on that project, we have servers that are 256 gig of RAM to accommodate right? So I mean, it's
That can hold a pretty big problem.
yeah,
Well, yeah, we actually, I mean, we needed special accommodations at our client to provision instances that would actually hold the problem in memory while we solved it. So that was a whole other, I mean, that's a whole other wave and a whole other ocean.
yeah, that was
But one of the things that I'm always curious about, I ask myself this all the time, like if I knew now about solving linear programming problems, if I knew what I know now 5.5 years ago when I started this, like what would I have done differently? And I'll start with you guys. Like what would you have done now that you have one or two of these under your belt? What are you taking away from previous projects that you're bringing into the next one when we do this again?
I think the biggest one is so both of mine are, we replaced an existing sort of process that did this stuff, right? And the problem with that was there was these people who had been doing this for years, so that nobody knew all the rules, right? There was the requirements weren't there, and so we had to figure them out. And so the whole process was just trial and error, right? Build a model, see what it does. Why didn't it do this? I don't know. Are we missing a constraint? Oh, we are. Build a new one. You know what I mean? Rinse and repeat. And so I think my first thing is I would just try to get a handle on, like, do you actually know the requirements? Because like in my experience, people don't really have all the requirements because it's not really their fault either. I mean, like going back to my original or my problem where it's like if you just built one of these naively and tried to optimize on cost, the first output you would get would be zero, right? It's just not intuitive, even from a developer's perspective. And so getting requirements and I guess setting expectations on what a LP is, just the amount of time, effort, depending on the size of it, but whatever timeline you have in mind, throw it out the door.
Yeah.
Right.
I'm kind of curious what your answer is.
I think that's all right. And I was going to add a loyalty card at the local bar because that would have saved me a couple bucks.
I did my best, dude.
You did good. Thank you for the drinks.
Yeah, and I feel like every bar within within the vicinity of whichever office we worked out of, I mean, neither one of us has to make an order anymore. Like they just come. Like, hey guys, how was it? Oh,
Usual.
yeah.
Do we need an optimization problem to work out which bar is best for you?
No, we don't.
We're actually those clients who just intuitively know, and
Yeah, that was a
yes.
brute force algorithm.
That's right.
trial and error.
Yeah. I don't know, Ben. What do you after all of these projects? What are you take away, and what do you bring into the next one?
I don't know how good of an answer I have. I think things went pretty smoothly. I mean, what I've got now is
That sounds amazing. No, kidding.
yeah, it went great. I think I've got the sort of the model in mind, and I could just do it faster next time. I also had a lucky situation where we really did know pretty well with the constraints, where it was all the properties that were, I mean, I can't build a problem without the data, and the data was there. And we were also replacing a system that already existed. It was a huge overhaul, and the linear programming needed to be completely written from scratch. But we knew the constraints, so that actually was something easy, and it wasn't bad to extract some of the details and nuances from the user. So I'm gonna keep thinking, but maybe can we move to Cam? Do you have any answers, Cam?
I'd say trying to make all of the stakeholders feel like that they have ownership in it and are collaborators, like all of those people who have been doing the manual process and know all of the constraints, whether they know them or not. Just getting them very involved and being like, we're building this together, and getting them excited that, like, when something goes wrong, they're not like, your system messed up, you're an idiot. If you get the relationship right, it can be like a collective head slap, like, oh, all of us forgot about this. Let's get it in there and keep doing better.
Ben brought up something interesting. I think one of the benefits that we had going into this is that we did have a legacy system, and the data quality that came out of the legacy system wasn't always the best, but we early on put in processes to like kind of migrate that and massage it into our needs. That was, I mean, the data quality going into these models is key, right? I mean,
Yeah.
outside Greg and everybody else said like a solid BA is probably the most important resource. It's more important than any of us, maybe aside from the mathematicians. But a solid mathematician and a solid set of data going into these, because that was a huge issue early on for us, right? Is like getting, we added so many dimensions to the data, but if we added dimensions to data that sucked to begin with, then the entire problem was screwed up. So
Chad, I want to jump in there. That was a huge takeaway actually from our project. We found data quality issues in the existing data because we rebuilt the thing from scratch and kind of just ran everything through a fine-tooth comb. And we found big problems that, I mean, I didn't do a cost estimate, but over time, those problems had been there for a long time. And it was, missing fields weren't being checked and so on. Uh, but yeah, data quality was sort of a side effect of our process.
Yeah.
Yeah.
Yeah, we found the same thing on both projects because we found data integrity issues that had been in their systems for years, right?
Yeah, yeah. This is sort of a benefit of hiring SDG to do something like this is that isn't going to be on the statement of work or whatever. Is we'll find things like this that we didn't even expect to.
Yeah.
Yeah, because the fact that we know nothing about anyone's process coming
It's a
in
benefit.
means, like we're asking what's up with this and
I noticed
about
that this
everything.
cost field is empty. Is that going to cause
Yeah.
problems for you guys? I feel like it should.
Well, and kind of add to Chad's thing, it's not only just the data integrity, not just the quality, meaning like, hey, are non-nullable fields null or not, but like actual live sort of business data. Like you can't build these with just mocked out data, or at least you can't. It's really, really hard to sort of verify that all your constraints and stuff are met. At least in the projects that we work on, because they're so large, the only people that can verify the output are the business people that have been there for 2 decades and kind of know what it should look like. And if you give them mocked out data, they're just going to say, well, I don't know what that is. Do you know what I mean?
Mhm.
And you can use mock data to kind of verify that the math is correct and whatnot, but
Are you not able to use historic data and sort of, simulate what should have happened yesterday and then what did happen yesterday?
um yes and no. I mean, we used production data
Brian's like, good idea, Ben.
throughout our test environment, but it wasn't the nature of the two applications that I'm working on now and that I worked on with Chad and Brian is historical data wasn't it's an always looking forward thing, and so you're always kind of looking at today and stuff, and so it's kind of complicated to answer, but yeah.
Yeah. So I mean, go ahead, Chad.
Well, I was just gonna say I literally did just build out a small tool, AI assisted, but that helps us validate, because one of the outputs of what we build now is we have so many reports. Like I don't know, Brian, what do we have? Like 2-3 dozen reports now that all spit out different numbers, cut different ways based on different inputs. And when we change the model, like there's no person that's going to go through all of those and say, oh, this one plant, this one day, this one, product type is off, right? So I kind of did what you're talking about, Ben. I built out a tool to automate kind of looking at all those and just identify variances of X amount, right? Like, hey, this is new code went in, new model changes went in, and this one, these reports are off by this much. So we're not necessarily validating yesterday's, but from today's all the time. I think the thing that is important for us to look at and pay attention to is when we touch the model, what are the exact outputs of that, and how do we identify when things change, when there's like literally thousands upon thousands of outputs of this thing, you know. That's right.
There's a kind of chicken and the egg problem there where we got these people that are core to the business. They've been running this stuff manually for years. We've talked about them. Well, they're very busy people because they do a lot. They're responsible for a lot of things. They're also the people that are helping us build the new application. And so sometimes trying to get their time to say, hey, come and look at this lower environment where the data doesn't match anything at all like what you're trying to solve today in the real business. Also, give us an hour or two of your day. It's I know that it's going to help you by the time that application is delivered, but also you got real world problems. So
yeah, our
Well,
SME,
and it's
like
hard to compare yesterday too, because the way you formulated for a product yesterday might not be the same way you would formulate for that product coming Wednesday, because the order quantity would be different. Maybe there's other orders around it that share the same resources that are stealing from it, or maybe your inventory is just different. You know what I mean? So like even the same product hardly ever gets the same formulation twice. You know what I mean? And so it's hard to just say, well, you can't just compare it to what it did last week and say, yeah, it matches, because it's not supposed to.
If you make a code change, it's hard to figure out the answer will look different, but is that a feature or a bug or just different? It's hard to put your finger on that.
Yeah.
Because then you get, well, why are we talking about this order? This order shipped last week. Oh, well.
It took supply from this. Never mind. Okay.
Anyway,
we're almost at an hour, I think, right?
Time flies when you're talking about linear programming. Jeez.
Oh man.
We could all go on for an hour, I could tell, or more hours. We could each go for an hour.
Well, lucky for you guys, it is close to happy hour, so we can actually do that if you wanted to.
I was going to look into loyalty cards. So.
Oh yeah.
Yeah, the bar loyalty cards.
Any parting thoughts before we wrap it up? I got nothing. This was great.
This is a good, I think, collection of projects. We have small, medium, and large. We have open source. We have sort of projects that require bigger software solutions. I like it.
Yeah, it's good to hear that everybody has kind of the same issues that I haven't seen. So that way it's because like right now I'm basically by myself on this. And so, some days it just starts to wear on you and I start to wonder like, wait, am I just doing this wrong?
Do we need a linear programming support group? I mean, we're here for you.
I mean,
there've been solo projects. Ben was by himself. I'm by myself programming the thing.
I don't think we need a support group. We need a support happy hour. We need an outlet for.
What are those rooms you can go to smash plates and stuff or whatever?
Yeah, that'd be actually
a rage room.
Yeah. Brian, how you doing?
Awesome. Yeah.
All right, that's Brian's parting thought, and we'll end on that.
I got nothing.
Thanks, guys.
All right, this was awesome. Thanks so much for hanging out, and we'll probably do this again. I'll see you guys at one of our loyalty taverns soon. All right, say goodbye.
Support meetings.
Yeah.
Bye.
All right. Later.
Solution Design Group is a digital product consultancy in Minneapolis. Check us out on the web at solutiondesign.com or look for us on Facebook, Twitter, LinkedIn, and Instagram at Solution Design Group.